Model, scaffold, harness, three words that mean something different at every AI lab. This year, Hugging Face, Anthropic, and OpenAI each published their own definitions, and they don't quite agree. Where the lines actually fall changes how you build agents. There's no settled agreement on what the core agent terms mean. At ICLR 2026, Hugging Face's Sergio Paniego and Eritrea Roy Ghostipati couldn't get a consistent definition of harness or scaffold from anyone they asked. Their blog post builds out common language for the field. These terms matter because they pin down how agents actually work under the hood. The harness and scaffold are where an agent's behavior actually lives, the layers around the core model that turn a text generator into something that acts. The harness is the execution layer. It calls the model, dispatches tools, decides when the task is done. The scaffold defines behavior, system prompt, tool descriptions, response parsing, context management. Paniego and Ghostipati propose thinking of an agent as model plus scaffold plus harness. They don't see this as a rigid definition that everyone has to adopt. Instead, they're offering a mental model, a way to structure your thoughts and have more precise conversations about what's happening inside these increasingly complex systems.
Long horizon work outgrows any context window, the problem effective harnesses exist to solve. Anthropic dug into it last November with a practical look at agents for long-running tasks. They define the harness as the framework that lets an agent operate coherently across multiple context windows, and they use their own Claude Agent SDK as an example of how this design can work. Context compaction alone doesn't cut it. Anthropic's argument is that pruning what the agent sees won't carry a long project on its own. What matters is deliberate architecture, how you scaffold the environment, how you track progress toward a goal, and especially the prompting strategies you use throughout. To illustrate this, they highlight an initializer agent plus coding agent pattern. One agent takes a product spec and breaks it into a detailed task list. Then another agent executes those tasks, one feature at a time. This isn't just about giving the model more instructions. It's about the harness layer doing structural work that the model itself can't handle. Think of it like this. The initializer agent isn't just asking for code, it's creating a roadmap before any coding even begins. It shows how a well-designed harness takes on responsibility for organization and planning, making those more complex, multi-step projects actually achievable.
Reliability is the harder problem, and OpenAI now treats the scaffold, not the model, as the core of agent design. They released their Building Agents learning track, and it really reframes how you should think about things. It isn't just about picking the right LLM, it's about everything around that model. Think instructions, what tools your agent has access to, and how those tools are orchestrated. For example, OpenAI specifically calls out defining custom functions as a key element. Those let you connect your agent to your own code or APIs. But they don't stop there. The track also covers using built-in tools like web search and the code interpreter. It's about giving your agent the right capabilities for the job. And it doesn't end with individual tool calls. The learning track dives into orchestration patterns, so you can build multi-step workflows that handle more complex requests. They're pushing beyond single interactions to systems where agents can actually plan and execute a series of actions. That brings us to the Agents SDK, which is designed for building networks of agents. You're looking at features like agent handoffs, passing tasks between specialized agents, and guardrails to keep things safe and on topic. Importantly, they emphasize session management as critical for production systems. You need a way to track conversation state over time if your agent's going to be useful beyond a single chat turn. Ultimately, OpenAI frames instructions, tools, and orchestration as the difference between a prototype and production, and they highlight input validation and structured outputs as best practices within that scaffolding layer. Getting those right is essential for building agents that consistently deliver the results you expect.
Operator arrived on January 23rd of last year, and it's a really good example of what autonomous AI can look like in practice. This isn't just about generating text, it's an agent that actually takes control of your web browser and does things for you. Operator is built around what OpenAI calls a computer using agent, CUA for short. This model combines the vision capabilities of GPT-4o with the reasoning power of some of their more advanced models, so it can see what's on your screen and then figure out what to do about it. Operator runs the familiar perception, reasoning, action loop. Read the screen, decide, act. No new theory there. What's notable is the interface. The whole loop runs through pixels in and mouse and keyboard out, the same surface you use. It maps cleanly onto the planner-executor split from earlier. Perception and reasoning plans, acting executes. OpenAI prefers CUA, but it's the same pattern. It iterates through this loop constantly until the task is complete, and it shows how you can build an agent that's capable of handling more complex, real-world scenarios than a single chat turn allows.
Across the field, the way people describe these systems has quietly converged, and a survey paper by Liu and colleagues published in March of last year quantified it, analyzing 329 papers on language model agents. They're finding the field is largely speaking one language now about agent architecture. Terms like harness, scaffold, planner, and executor are consistently defined across most of the research, as are concepts like tools and how agents use memory. That's a big step forward. It means you can read work from different labs and actually understand what they're building. The survey breaks down agent systems through a methodology-centered view, which essentially maps out how these pieces fit together. They see a clear evolutionary path, starting with single agents, then moving to designs incorporating two agents, and eventually more complex multi-agent collaborations. These collaborations take different forms. You'll see architectures built around planners handing off tasks to executors, or coders working alongside reviewers, all the way up to systems where roles are specifically separated between agents. Consistent vocabulary doesn't mean solved problems. The paper flags several that remain open. Long horizon planning, getting an agent to reliably achieve goals that require many steps over a long period of time, remains difficult. So does mid-task replanning, figuring out how agents adapt when things don't go as expected. And coordinating multiple agents effectively, still very much an open question. If you want to dig into the details, a curated companion repository is available on GitHub. It's a really good place to get your bearings if you're serious about building these systems.
Notice where all of this is heading. The hard problems in agent building are shifting out of the model and into the architecture around it, the harness, the scaffold, how context gets managed. And every framework we covered shares the same unsolved gap. When a long-running loop breaks mid-task, none of them recovers. They start over. Mid-task recovery is where we're going next.